Good evening, welcome to my laboratory. This is the circuit schematic that I'm going to be demonstrating today, and I hope I can get this done before something actually blows up. So anyway, I put in this little capacitor here, and actually I've shorted one of those capacitors already, so I have to replace it. And there's the output side, and at one point I'll be actually disconnecting these guys and or putting an incandescent bulb across there. I have this this is a 110 volt 15 watt incandescent bulb. The filament measures 100 ohms cold. Okay, and let's see, what else? Oh yeah, over here's how I'm monitoring things. I have the digital multimeters in here. Then I also have 0.22 ohm 2 watt current viewing resistor in the negative rail to the emitter, and then I'm looking at that, the voltage drop across that resistor with the A channel of the oscilloscope, and the B channel of the oscilloscope is monitoring the output voltage at the output of the secondary coil there. Okay, so that's how we're input power monitoring, and then our output voltage monitoring. Okay, and for the base resistor I'm using this combination here. Okay, and so and oh yeah, and I'll be using the I'm driving it with the Elenco power supply, and one of the things I want to show is how this thing kind of freaks out in my power supply. Right now I've got the knob turned kind of up, but there's not a lot of voltage happening. This is supposed to be able to put out 2 to 20 volts at up to 2 amps. It'll actually go a little bit more than that. The yellow line stops at 3 amps there on the meter. Okay, so anyway, right now this is what the inline meters are showing. 1.64 volts and a little bit over half an amp, and got the LED glowing, and this is what the waveform looks like. Okay, so we're at 50 microseconds per division horizontally, and this is the B trace here with the baseline indicated right along that radical illuminator or radical line, and then this is the A trace, which is the current, the voltage drop across that resistor. And it turns out that let's see, we're at 1 volt per division on that scale, and it's a 0.22 ohm resistor, so 1 volt of voltage drop is going to be about 4.5 amps of current. Okay, and over here on this one we're at 20 volts per division with a 10x attenuated probe, so that's 200 volts per division. So right now it's showing a little bit, slightly over 200 volt peaks there in that oscillation, and that's the output that's measured here with respect to the ground reference. Okay, and that frequency, I've computed it already, that frequency is about 43 or 44 kilohertz going across there. Sorry about the light. Alright, now let's see if I can get this to work. Now what I'm going to do is crank up the voltage on the Elenco, and you can see that the frequency decreases a little bit as I do that. I'm cranking up the voltage, but the strange thing is that the indicated voltage and the current don't change much. Now I've got the knob all the way up to the top stop on the Elenco, and got a good bright neon, but that's all that we get. And but you can see that the current has gone up, so we've got maybe 3 amps or so of current in the peaks, and then it averages out to about 1.3 amps or so. but the voltage seems low, right? Oh yeah, I have this stack of filter capacitors, but I'm not using them right now, so we're just feeding the Elenco's output voltage directly into the circuit. Alright, so let me crank this back down a little bit to where the bulb just kind of goes back to these ordinary power levels. Okay, now what I'm going to do is take this 220 ohm wire wound resistor and short from the collector to the bottom end of the coil. So I'm basically shorting from here to here with this resistor. Okay, and so there's the waveform. I'm not going to change any power supply settings. I'm just going to go like that. Okay, and I guess you can see that the brightness of the bulb changes when I do that, and I get a waveform that looks like that. Here's before, there's after, and if I give it a little bit more voltage and then do this, well, maybe a little more voltage. There. Now I've removed that resistor and we've stayed in this second mode. Whoops. Let's get it back. Okay, so I just flicked it with the resistor again. Come on. Maybe need a little bit more voltage there. Okay, so now hopefully it'll stay in this second mode here. The frequency there now is down to about 10 kilohertz. Okay, the bulb is glowing brilliantly, and I have much more normal behavior on the Elenco power supply. That is, when I increase the voltage, the current goes up, but the frequency also goes up. And over here I get the right voltage and current indicated on my digital multimeters. Here I'm up to the stop, 20 volts, about 1.5 amps. This is 8, almost 10 amps in those peaks there. But it still averages out to about 1.5 amps. And the bulb is glowing brilliantly, and I can hear a little bit of oscillation. Hear it humming at a high frequency. But that neon bulb is still neon orange. Okay, so now I'm going to crank it back down to where we get that shift to the first mode there. The bulb is out, and there I've started the bulb just with the usual process of doing that. Shifted it to this oscillation mode. I can usually get, okay, so there the bulb is on. We're back down to these kinds of current values with this high oscillation. All of this has been with this capacitor out, that is, the switch is across here. Now I'm going to switch this little capacitor in, but first we'll pause in the middle, that is, with this switch open. It's just open now. And here is an oscillation. That is a no-load oscillation. It consumes very little current, and it's at a much higher frequency. I'm going to change to 10 microseconds per division, so you can see that that's a nice sine wave, perfect sine wave. This is at 1 microsecond per division. Now we'll go back to 50, and that frequency is 225 kilohertz. Okay. And so now what I'm going to do is switch to the with the capacitor in. So now that's with this little capacitor in here. So now we've got this mode of oscillation. The neon is starting to change color. It's starting to get a little purplish in there. This is about 80 kilohertz here. See what that looks like. 80 kilohertz, and we've got about 3.5 amps or so in those input. And now, in this mode, I'm going to go ahead and crank up the Elenco power supply. Let's see if we can catch what happens to that. Here we've got massive, this is, remember this top is at 200 volts per division, so that's 2, 4, 6, 8. That's over a kilovolt there. And the neon, that's what we're going in. And the neon is kind of changing color a little bit, I think. I may have already blown out that little capacitor. So here I've killed the oscillations, but that's okay. I know how to start them again. Like that. And then okay, now when it's in this mode, this is the time to light up the bulb by just placing it across there. Okay, that's kind of dim, right? So we're not actually in the buku mode yet. Let's see here. There we go. That is amazing. That is much, much brighter than the Elenco will actually light that bulb. And also the Elenco is putting out a lot more than its correct amperage. Okay. And now we're back to this mode. I've turned the Elenco down. More normal stuff. Now, a very interesting thing is happening. This neon is starting to, the glass in it is starting to darken. I don't know if you can see that or not. I've never seen this happen to a neon before, where the glass itself gets dark like that. I've had that happen to some of my other incandescent bulbs that I'm driving with these kinds of high frequencies. It's doing something to the glass. Alright. Let's open that circuit and there's that nice beautiful sinusoidal oscillation there. That's the one that gives me the really high voltages. Woo. It's so high that it even shorts out my switch. Can you see that? The neon is glowing even though the switch is in the wrong position. That's because there's been a little arc in the switch, I guess. Okay, thanks for watching.